In the incline examples that we have been through so far, we have always launched a projectile upwards. In this lesson, let's launch it downwards and we shall see what the differences are. So this is how a projectile will be launched, that is, down the incline. The angle of inclination of the incline is beta, and the launch angle is alpha. But when a projectile was launched up an incline, we measured the angle anti-clockwise from the plane of the incline. So alpha is measured anti-clockwise here. And when the launch is downwards, we are measuring the launch angle alpha clockwise from the plane of the incline. So what changes would we have to make in order to accommodate this? Let's begin with the total time of flight. The one thing we would do is to continue using the older formulas that we had developed. But in those formulas, instead of using the acute angle alpha, we substitute it with the obtuse angle 180 minus alpha because that is measured anti-clockwise from the plane. And that way the formula will be consistent in the sense that the angle is measured from the plane of the incline anti-clockwise. So if this angle, which is the angle of launch here, is alpha, then this angle would be 180 minus alpha. Or in other words, we can imagine it as if the launch is still up the incline, but the angle of the launch is 180 minus alpha, because alpha is now this angle. So if we substitute 180 minus alpha into the equation for the time of flight, we would obtain the time of flight as 2v0 sine of alpha over g cos of beta, which is exactly the same when launching it up the incline. This is since sine of 180 minus alpha is sine of alpha. So if we launch a projectile up an incline at a certain angle alpha, we obtain the same time of flight as launching it down an incline with the same launch angle. You could also try to verify this by deriving the time of flight exactly like we did when we derived it up an incline. The procedure would be identical. What about the maximum height? Would that be the same too? In the maximum height equation, we do the same. We substitute 180 minus alpha for alpha, and since sine of 180 minus alpha is the same as sine of alpha, again we arrive at the same expression for the maximum height as we did for the launch up the incline. So a launch with a launch angle of alpha up the incline or down the incline gives us the same maximum height. Also, you could try verifying the result by deriving the maximum height exactly like we did when the launch was up the incline. The same concepts, the same procedures are to be followed. Now the time of flight is identical when the launch is up the incline or down the incline. The maximum height also remains unchanged whether the launch is up the incline or down the incline. Now what about the range? In the range formula, we again substitute 180 minus alpha for alpha, and we make this substitution within the sine part of it and within the cosine part. Now sine of 180 minus alpha will be sine of alpha, and cos of 180 minus alpha plus beta would be cos of 180 minus alpha minus beta, which is minus cos of alpha minus beta. So we have a negative range here. What would that mean? The negative range means that we are measuring the range in the negative direction of the x-axis here, that is down the incline, and the positive x-axis is up the incline. But what we are really interested in is the magnitude of this range, and we find one small difference from the formula when the launch was upward. When upward, inside the cosine part, we had alpha plus beta. Now we have alpha minus beta. So this term is reducing, and therefore its cosine would be increasing, which would increase the range. This would mean that when we launch a projectile down the incline with the same speed and with the same launch angle, although the time of flight remains the same, the range increases. So if we had launched it upwards from this point, it would not reach the top of the incline. It would fall short, maybe somewhere here or here, but it wouldn't reach this point. What could be the possible explanation for this? The reason is this: when you launch down an incline, both the initial velocity along the x-axis and the acceleration component along the x-axis are in the same direction, so the displacement in the same time would increase. And when we launch it up an incline, the initial velocity component points up the incline, whereas the acceleration is in the opposite direction, which is down the incline. In case you want to derive it, like the range up the incline, this is the only point that you have to remember. That is, that the initial velocity and acceleration have the same direction down the incline. And finally, we come to the maximum range. Launching up the incline, the launch angle had to be 45 minus beta over 2 to get to a maximum range along the incline. But when launching down the incline, the launch angle has to be 45 plus beta over 2 to get to the maximum range along the incline. So the difference is the plus sign between the 45 and beta over 2. When we launch a projectile down an incline, the time of flight and the maximum height attained is the same as when the launch is up the incline. The range, however, increases when a projectile is launched down an incline as compared to up an incline. This is because the initial velocity and the acceleration components along an incline are both in the same direction.